So hi everyone and welcome to this open demo. So today we will talk about the subject of Edge and how OpenShift and its ecosystem can help us. So if you can go to the next slide. So to do that, today we'll be in the context where we are shipping companies, and our job will be to track shipment from one warehouse to another warehouse in different cities. So you will see like 10 different warehouses in 10 different cities in Europe, and one headquarters that will control the traffic from one to another. And we will try to use OpenShift to help us following all that traffic. If you can go to the next slide. To do that, each of our shipment will have a tracker that will be our RFID tag that will help us to follow the shipment. And to do that, we will have in each of our warehouse 2 tag readers, one for incoming shipment and one for outgoing shipment. Then we'll have the headquarters that will collect all the data that will be recorded by our RFID tag readers, and that will help us to show it in a map where we'll be able to track and follow our shipment. Here I present to you the architecture that we're going to deploy. So it's divided in 2 ports, warehouse ports that will be a namespace for each city, so Paris, Varsovie, etc., and a headquarters that will help us to follow, and that will where we will have as a final result the map that you can see on the top left, and that we will see at the end. To do that, we'll have 2 ESP devices that you can see on the bottom of the architecture document. That device will send the ID of our parts of our shipment to MQTT brokers. Then we will have a camel case that will enrich that data to add some useful information that will help us to have, like an example, the timestamp and the information that we need to format the ID. Then all of that data will be sent to Kafka brokers. And finally, we will mirror that Kafka brokers to the headquarters. And on that headquarters, we have all the topic for each different cities, for each different warehouse that we have created in the different ports that was before. For the next part, I let the hand to Nicolas for the headquarters.
So the data collected from the Kafka broker in each warehouse is sent to a Kafka broker, which is in the headquarters. This Kafka broker is then read by a Camel Quarkus application that will enrich the data. So from which warehouse the data is coming, timestamps, and so on. And those data are sent and aggregated into one Kafka topic. And then we have a stateful Kafka stream processing, which transform location data into shipment. The reason we are doing this is that the ESP devices collect location data. So this parcel has been seen in this warehouse at this time. But to get a shipment, you need a source and a destination. So that's why we need a stateful Kafka stream processing to join 2 location events into one shipment with a source and a destination. That shipment information is sent again to the Kafka broker into another topic, and that topic is read by a map, an application in the headquarters, which displays the warehouses and the location of the parcels in real time. This application is written in Quarkus, and it shows what we can really achieve by using cloud-native technologies. So let me show you in OpenShift how it looks like. So the headquarter is deployed as several pods, and some of the pods are the Kafka broker deployed using a Kubernetes operator. Along this Kafka broker, you get a pod for the camel enricher, so the processing done by camel to enrich data. It's deployed as a pod running on Quarkus. And there is also the map, which displays parcel moving in real time, and the stateful stream processing using Kafka streams, again on Quarkus. And the last part is Mirror Maker. Mirror Maker will connect to all Kafka brokers running in the warehouses and collect data from them. So as you can see, everything is running on a single namespace, and so you have to imagine that other warehouses are deployed throughout Europe, each one on a different OpenShift environment. Of course, for the need of this demo, everything is deployed on separate namespaces. And after that, my colleagues will show you how you deploy all the needed software components that are in the warehouses. So you will see how we deploy an MQTT broker. You will see how to deploy Kafka, how to configure Camel, and how to program those ESP devices. So by the way, let me show you those ESP devices. So it's on the screen there, you can see our two devices there. There will be more later, but for now we have two ESP devices. And those ESP devices have two parts. One is the microcontroller, and another one is the RFID reader. The MQTT connects over Wi-Fi to the MQTT broker to send the red tag identifier. And when you use an RFID tag like this and put it on the ESP read the ID and send the ID to the warehouses, and the warehouse send the data to the headquarters. And at the end, you should see parcels moving on the map like this in real time. So each time an RFID tag is read, you get a parcel which is moving from one warehouse to another. So let me turn to Sébastien to present the MQTT in ESP part.
Okay, hello everyone. So let me share my screen first. Okay, looks good. Sorry guys. Okay. So I guess you can see my screen now. So I will explain you how to deploy the MQTT broker on our warehouse. So I will focus on one warehouse, so the Athens warehouse. And so we have a documentation that is online so that this demo can be reused by you guys if you have an OpenShift cluster, of course. So we need, before starting the MQTT broker, of course, you need some tools installed on your laptops. So basically we need the OC command line for OpenShift. And also what we will need to develop on our ESP is an extension to VS Code, which is called Platform.io IDE. which basically is an extension of for VS Code that allows the communication with the ESP itself. I will show you that a little later. So now let's start to deploy our MQTT broker. We, as it has been explained earlier, we will use two ESP, and for now I will only focus on one. So let's start. As you can see on my screen, I'm using the warehouse Athens, and for now nothing is deployed on it. The only thing that is deployed is that we are using some operators that are already installed. We have done that previously. So a few operators have been deployed, so one for MQTT, one for Kafka as well, and a few other ones. So to deploy our MQTT broker, we just have to copy paste that, and basically, yeah. And automatically, the operator is deploying our MQTT broker. Also, we need to, of course, to expose our MQTT broker, and for that, we will create a service, a load balancer one. We are using, actually, OpenShift is deploying on AWS, and by having a type of load balancer, automatically, an ILB on AWS will be created by that way. So let's copy paste our service. And as you can see on the right, we now have an AWS.com address for our service. So now our MQTT broker is exposed to internet. So now we have to create two topics on our MQTT broker, one for the input parcels and one for the output parcel, meaning that when you are going to the parcel is going to enter the warehouse, we're going to in. When it leaves the warehouse, we are sending a message to the output, to the out topic. So let's create that. Same thing, we are just copy pasting. So we now have the in topic that has been created. We will check later what has been done. And copy pasting the out. So the only difference there, as you can see, is just the address name, in and out. All right. So now we can check what has been deployed. And for that, we check that, and that. A bit easier that way. So we have our MQTT. We have our MQTT load balancer service, and our two topics. If we are going to the topology, we can see that we have everything that is running there. So let's test now. So this is the what I just showed you, and we will just do a quick test by sending fake messages to the MQTT. Now we'll zoom in. So what I'm doing here, I'm just listening to the topic on our load balancer, on our Kafka broker. So On the top, I'm just listening, and I will send some fake messages just to test. So as you can see, we are receiving some messages. So that was for the in topic, and we'll test as well for the output. And yeah, that's good. All right. So for the MQTT part, that's okay now. And I let the mic to my colleague.
Okay. I'm going to share my screen.
Hope it will be better than me.
Can you please stop sharing yours? I think it would
Done.
be easier.
Yeah.
Okay, I also have an issue that I didn't have yesterday. Okay, I need to leave and come back in the call.
Same as you, same as me.
Okay.
Okay, so while my colleague is reconnecting, I will show you another part of of what is going on. Basically, so as it has been explained, we will try to flash our ESP in order in order the ESP can connect to the Wi-Fi and it will be able to send the parcel number. And for that we need to develop and flash our ESP. So let's do that. So yeah,
here is the ESP, and it is in two parts. So we have the ESP itself and a RFID reader that will be used to get the tag ID.
So first we are connecting our device to our laptop. We need a few libraries in order that the DSP, in order to help our development. So we need one libraries in order to allow DSP to connect to the Wi-Fi, and just another one which is called PubSub client that will allow the ESP to connect to an MQTT broker. So here in this example, we have an example of the code that we will use to flash our ESP. So it's quite simple actually, and you just have to set three things in fact. So there we have the DSS ID of the Wi-Fi, the password of course, and we need to also put the load balancer URL. So let's go to the VS Code. I hope you can see it. Okay, so I have pre-configured my VS Code in order to do that. My ESP is connected to my laptop, and I will just build, thanks to Platform.io that I previously talked about. Thanks to Platform.io, I can build my code directly. So let's build it. And I forgot to put my MQTT. that I get here. So let's do that. So I'm building again, building and uploading. So the code has been built locally, and right now it's pushing to, it's flashing the ESP itself. So takes a few seconds. Okay, that looks good. And let's check. It should be okay. Yes. So as you can see, now the ESP has it connects to the Wi-Fi, it gets an IP address, and then it connects to the MQTT broker. So I give the mic to my colleague now.
Okay, this time I can share my screen. Okay, so now you're able to see my screen. I just want to do a very quick recap about what we've done so far and where we are going next. So far, Sebastian deployed the MQTT broker, and as well he flashed the microprocessor. So the message basically can pass from, when you scan an RFID, it is sent to the MQTT broker. And now what we want to do next is to store this message into a persistently Kafka broker. And before sending it to the Kafka broker, we want to parse the message, transform it a bit, like you might want to add a timestamp, or you also might want to transform the message to change it into a JSON format. So this is the main point of the Camel-K integration in between the broker, the MQTT broker and the Kafka broker. So first of all, I'm going to deploy the Kafka broker, and then we will see the Camel integration. So I'm going to show you what does it look like. I'm not going to deep dive into every single line, but I just want you to know which object is involved and a few points. So yes, this is the Kafka instance, the Kafka cluster on the warehouse. So basically, what we have is two listeners. One is encrypted with TLS, and we are going to communicate to send data to this Kafka cluster with this listener. We have on the top here, near line 9, we have few configs like the replication factor or number of replicas, etc. And last thing is that we will ask a Kafka operator not to create any certificate authority, because we want to control and have the same way of encrypting and authenticating throughout the headquarters and the warehouses. Okay, so I'm going to. So yes, as I told you, we will have our self-certificate authority. So this is what I'm going to deploy as first in two secrets. So let's do it. Let's clear that. Where am I? So let's do an OC apply of first the certificate authority. Then let's deploy the Kafka cluster. We will wait a bit and see what's happening in the namespace in terms of pods. First, let's deploy two other things. What we need to do next is to enable the headquarters to get the data to mirror our Kafka topic. And in order to do so, we are going to create what we call a Kafka user. It's just a way to authenticate with user password method so that the mirror maker can connect to our Kafka. So this is what I am deploying right now. Here is the Kafka user, and it is referencing a secret right there. And so I'm also deploying the secret here. So let's do that. OC apply Kafka. First, the secret of the user containing the password of the user. Next, the user itself. Finally, we need two topics, one topic for incoming messages, one topic for outgoing messages. So yes, for the incoming shipments or parcels and outgoing ones. So let's deploy the two topics. Okay, so let's see what we have in the namespace. So I'm in the warehouse namespace. The first pod here, it corresponds to the MQTT broker Sebastian deployed. And here we can see that we have deployed our Kafka cluster and also the Zookeeper instances. So everything is fine, we can go ahead. So next thing is to deploy the Camel integration. Same as before, we need a Kafka user so that Camel integration can connect to the Kafka broker in a secure way, and so we really know which user is doing what. So in the same way as previously, we create a Kafka user for Camel, referencing a secret, and so first I create the secret. So let's deploy the first two objects. OC apply Camel. First the password, then the user. Next thing we need to do is to deploy a Camlet. This Camlet, basically, it is used to connect to an external system. This external system is our Kafka cluster. So the Camlet it will enable us to connect in an easy way to the cluster, so we can send the message quite directly and simply. And so what we'll do next is to create a Camel integration. And so we can see the content from line 8 to line 14 here. And so if we go line by line, we'll see first we have a from here, which reference MQTT broker. So it will take the message from the broker. Next, on line 9, it will set a header. Then it will convert the body. Here on line 11, we see that we have the enrichment part. We had here a timestamp with a new date. Then we convert it to JSON. And finally, we send it here. You can see the camel thing here. So we send it to a camel, and we have like the Bootstrap server, the service host name of the Bootstrap server, some port, and you can see here that I'm referencing the user I just deployed before, as well as the password and the topic where I want to send the data. So we have two integrations. One for the incoming topics and one for the outgoing topics. So let's deploy it all. So what I need to do is to deploy the Camlet. Once the Camlet is deployed, I can create the first integration and finally the second integration. Okay, so if we watch in the namespace what changed, what happened, we can see here that I have two pods corresponding to Camel integration, one for incoming topics, one for outgoing parcels, one for outgoing parcels. So yes, basically we have deployed everything needed to pass the data, to send it from the microprocessor through the headquarters. So now it's time to play and test. I will stop sharing my screen, or maybe I will share my screen again to the shipment map. or maybe you, because you have the webcam. So I will not going to share my screen.
Okay. So you should know almost. You should almost see my screen. Let me share it. So share screen. There. Yeah. Okay. Okay. Good. Shipment. Okay. Okay. Good. So on the screen, on the right side of the screen, you see the three ESP that have been flashed and connected to the MQTT broker. And on the left of the screen, you can see the worldwide map with all the warehouses. And if I take an RFID tag, I should be able to show you data moving from parcels moving from one warehouse to another. So you can see the parcels moving from one warehouse to another. Using so each time the ESP reads an ID, it sends it to the MQTT broker, transformed using Camel to Kafka. Kafka brokers are collected by the mirror maker, sent to the headquarters of Kafka. Then it's processed, as we saw, and displayed on the map. So let me maybe conclude this by the lab, because what you saw today is a demo, but we can do exactly the same by you can do exactly the same in a lab. So that's something that can be replicated on customer sites to show the value of Red Hat products in the context of edge computing. And so we use participants and dispatch them among tables. Each table will be a warehouse, and 6 people per table will be responsible for setting up the whole IT environment of a warehouse. So everything you saw in the OpenShift cluster. And at the end, you can take an RFID tag, and you can move from table to table, and you should be able to see on the screen your parcel moving on the map. So that's something quite fun and engaging. We have been delivering internally at Red Hat in the past month, and with very good feedback. So if you are interested in, just get in touch. So maybe it's time to get the questions and answer your question.
Maybe.
I have a couple of questions. So John is asking, is there any particular recommendation for sizing Kafka clusters available?
There is some documentation about the subject that we can share with you, but it will depend of your use case. So hard to give like a direct answer, but I can share with you some documentation about that topic.
Okay, great, terrific. And we have another one. Is MQTT a requirement for this particular use case? And is gRPC an option?
What we can say is that MQTT is well suited for computing devices with very limited power. So an ESP is a microcontroller, so it does not even run Linux. It doesn't even have an operating system. So it's very, very tiny, and it cannot do something too complicated. MQTT is well suited for this, but of course, if there is a strong requirement to move to HTTP or gRPC, that's something that can be done, but usually it's at the expense of power consumption and autonomy.
Okay, thank you very much. Any other questions someone wants to ask? Okay, no more questions. So thank you very much, everybody, for your attendance, and thank you guys for this beautiful demo. We'll see you in a couple of weeks. Goodbye.
Thank you.
Thank you.
Bye-bye.
Bye.